Hi, I'm Pastor Robert Case. Welcome to a lecture on science and the Bible. Many people have been led to believe that God used some form of evolution in His creation process and that it took Him billions of years. Almost everywhere we read that the Earth is 4.5 billion years old and that scientists can use carbon-14 to date ancient fossils. But just how accurate are these dating methods? Most textbooks and journals never explain how the dating methods work, nor do they mention the assumptions involved. Mike Riddle, who has studied this topic for over 20 years, has presented the scientific and biblical evidences on origins throughout the United States. He has spoken in hundreds of churches, schools, universities, homeschool conventions, and at NASA. In this presentation, Mike presents information about the assumptions and processes used in carbon-14 and other radioactive dating methods. Let's join Mike as he speaks on the topic, dating fossils and rocks.
Dating fossils and rocks. Our roadmap through this talk will be this. We'll start with a primer on radioactive decay, what that means. Then we're going to go into a lot of detail of carbon-14 dating. Then we'll finish up with something called radioisotope dating. So we're going to cover the entire realm of the dating process. So let's start here, our primer on radioactive decay. To get into that, we need to understand what the atom is. Well, first of all, the atom is our fundamental unit of matter. And it's made up of components called subatomic particles, such as we have something called the proton, which is our positive charge in there. We have our neutron, which makes up our no electrical charge component. And those two, the proton and neutron, make up what we call the nucleus of the atom. Then going around that, we have what is called the electron, which is the negative charge. So our atom has these three subcomponents, protons, neutrons, and electrons. Now, that helps us understand what we mean by carbon, which is going to be one of our components of this talk, carbon-14. So what is carbon? Well, carbon is a lot of times referred to as C14 and sometimes as radiocarbon, like radioactive carbon. Now, there's many different types of carbon atoms. We refer to them as isotopes. We have carbon 9, 10, 11, 12, 13, 14, 15, and 16. Now, what distinguishes these different types of carbon? Well, the first thing we need to understand about carbon is all types of carbon have 6 protons. It is the proton that gives us the type of element we're talking about. All types of carbon have 6 protons. However, different types of carbon can have different numbers of neutrons. So the proton is what gives the atom its atomic number. Then when we add together the number of protons and neutrons, we get what is called the atomic weight. And that's what we refer to as carbon 9, 10, 11, 12, 13, 14, 15, and 16. So for example, carbon-14 would have 6 protons and 8 neutrons. Something like carbon-12 would have 6 protons and 6 neutrons. And carbon-13 would have 6 protons and 7 neutrons. So all types of carbon have 6 protons. Now we also have something called unstable isotopes or unstable atoms. An atom is generally considered stable if the number of protons equals the number of neutrons in the nucleus. For example, we have something called stable carbon, which is 6 protons and 6 neutrons. We have stable nitrogen, 7 protons and 7 neutrons. All types of nitrogen have 7 protons. Then we have stable oxygen, 8 protons and 8 neutrons. All types of oxygen have 8 protons. But then there is carbon-14, an unstable isotope. It has 6 protons and 8 neutrons. So now, what do we mean by radioactive decay? That is when the nucleus of the atom decays or generally changes into a new element. In other words, the proton number has to change. For example, we have carbon-14 radioactive decays into nitrogen-14. Now what's happening there? We have carbon. All types of carbon have 6 protons. All types of nitrogen have 7 protons. So to change from carbon into nitrogen, we have to add a proton in there. So that's what we mean by radioactive decay. the element can physically change into a new type of element. In other words, carbon can change into nitrogen. Now, how long does it take this change to happen? Well, the rate of decay is actually measured in something that we call half-lives. The half-life of carbon-14 is about 5,730 years. Now, what do we mean by half-life? Well, let's start here. Let's take an illustration. Let's suppose I have a complete jar of carbon-14 atoms. At time 0, this jar is filled with carbon-14 atoms. After 5,730 years, what will be in this jar? That would be considered one half-life. Half the amount of carbon-14 will have decayed. In this case, it decays into nitrogen-14. So after 5,730 years, what would be in that jar would be half carbon-14 atoms and half nitrogen atoms. Now, after 2 half-lives, or about 11,460 years, what would be in that jar? Well, it would be a fourth full of carbon-14 atoms and about 3/4 full of nitrogen atoms. So carbon-14 is what we call an unstable isotope, and it is constantly decaying. Now, if carbon-14 is constantly decaying, will we run out of carbon-14 in the atmosphere? And the answer is no. See, carbon-14 is constantly being produced in our atmosphere. Now, how does this happen? Well, first of all, we have these things called cosmic rays coming down from outer space. These cosmic rays come down and bombard our upper atmosphere. Now, what is our atmosphere mostly made out of? Well, it's mostly made out of nitrogen and oxygen. And these cosmic rays come down and bombard the upper atmosphere and with tremendous intensity change some of the nitrogen into carbon-14. So we have this collision of these cosmic rays causing some of the nitrogen to be converted into carbon-14. Now this carbon-14, once it's formed, combines with oxygen in the atmosphere to form something called carbon dioxide, CO2. What happens with this CO2? Well, it gets taken in by the plants, it gets taken in by all things that are living. So all living things eventually get carbon-14 in them. Now, do rocks eat or breathe? No, they do not. Therefore, rocks cannot be dated with carbon-14 dating process because they don't have carbon-14 in them. Only once living things or organic material can be dated using the carbon-14 dating method. So carbon-14 is constantly being added into the atmosphere, and we also know it is constantly decaying. So here's the full life cycle of carbon-14. Cosmic radiation comes down, bombards the upper atmosphere, converts some of the nitrogen-14 into carbon-14. Again, that's a proton-neutron change. Then over time, that carbon-14 gradually decays back into nitrogen-14. Again, it's a proton-neutron change. So the whole life cycle is we start with nitrogen, gets converted to carbon-14, then gradually decays back to nitrogen where it started. So carbon-14 is constantly being added to the atmosphere, and it is constantly being removed. Now, understanding that helps us understand the carbon-14 dating method. So let's do a quick review of what we've gone through. First of all, there's different types of carbon. There's stable and unstable types of carbon. An unstable type of carbon is carbon-14. It's got 6 protons and 8 neutrons. Then we had something called radioactive decay, which means that one element can radioactively decay into another element. For example, we use carbon-14 decaying into nitrogen-14. It's a proton-neutron change. Carbon becomes nitrogen. Then we talked about the half-life. Half-life of carbon-14 is about 5,730 years. That's the time it takes half the amount of carbon-14 in the atmosphere to decay. But not to worry, because carbon-14 is constantly being added to the atmosphere through cosmic rays. So the full life cycle we saw was we start with nitrogen-14, it gets converted into carbon-14, and then gradually decays back into nitrogen-14 where it started. So that's what we've gone through so far. Now, our next topics here will be something called equilibrium, which is going to be very important in this process. And then we're going to take a look, how does the carbon clock work? So let's start with something called equilibrium. Again, carbon-14 is constantly being added to the atmosphere, and is constantly being removed through radioactive decay. Now, here's the concept. When we talk about equilibrium, what we're saying is the amount of carbon-14 in the atmosphere is stable. In other words, the amount being added is equal to the amount that is being removed over a period of time. That is critical to this whole process. Let me give you an illustration here. Illustration. Let's suppose you have a bathroom sink. And you take that bathroom sink and you turn on both faucets full speed. Now you have a bottom part of that sink where the water's going out. But as the water's coming in, it's coming in much faster than it can go out that one bottom hole. So what happens to the water level? Well, it gradually builds up and up and up and will eventually overflow that sink because it's coming in faster than it can go out that one hole. But if you were to take your bathroom sink and put holes all up and down the side here, then turn on both faucets, what happens? Well, gradually it starts to build up and up and up, but eventually that water will reach enough of the holes so the amount that's coming in will equal the amount that is going out the holes, and we have a level of water there that stays what we call equilibrium. The water level stays the same, or equilibrium. That's what we mean about equilibrium when we talk about carbon-14. The amount of carbon-14 being added to the atmosphere is equal to the amount that is being removed. If that is true, then we have what is called equilibrium. When we talk about carbon-14 dating, we have to have a starting point. What's our starting point in this clock? Well, it starts when an animal dies. See, when something is living, when a creature is living, it's eating and breathing, taking in carbon-14. But once that creature dies, it is no longer taking in carbon-14. At that point, what is happening? The carbon-14 in that dead organism no longer taking in carbon-14, but the carbon-14 that is in that organism continues to decay. So we start the clock when an organism dies. Well, let's take a look at this. So the carbon-14 dating method relies on measuring the amount of carbon-14 in a fossil. Now, there's three scenarios that could happen here when we do this dating. Number one, we find a dead animal, a dead organism, and we discover there's a lot of carbon-14 still in that fossil. What would that mean? That would mean this creature has just recently died. In other words, not enough carbon-14 has decayed out of the animal. It has not had enough time for all the decay process to go through. Now, here's another scenario. Number two, we find a fossil, and we find very little carbon-14 in that fossil. Now, what does that mean? That means this creature has been dead for a long time, because a lot of the carbon-14 has had time to decay out. Because remember, once a creature dies, it no longer takes in any carbon-14, but the carbon-14 continues to decay. Now, scenario number three, there's no detectable carbon-14 in this creature. What does that mean? Well, if we find no detectable carbon-14 in this creature, that means it's been dead for a very long time. Generally, the belief is over 60,000 years. See, based on the half-lives of carbon-14, after about 10 half-lives, that's about 60,000 years, all the carbon-14 should have decayed out of an organism. So if we find a lot of carbon-14, recently died, maybe within the last 5 or 10,000 years. If we find very little carbon-14, it's been dead for a long time, maybe over 30,000 years, maybe up to 50, 60,000 years. If we find no carbon-14 in this creature, that means it's been dead for over 60,000 years, and we cannot do carbon-14 dating on it. So what do we need to know to do this carbon-14 dating? What do we need to know to determine how many half-lives have expired? Because that's the key to this. Well, two things we need to know. How fast it decays. Well, that we know. That's measured in half-lives, and the half-life of carbon-14 is about 5,730 years. The second thing we need to know is the starting amount of carbon-14 in that organism. When it died, how much carbon-14 was in that creature? That is a very critical detail. Let me give an illustration here. You walk into a room and you see a candle burning. And you measure this candle, the burning rate, and you find out it's burning about 1 inch an hour. So now we ask the question, how long has that candle been burning? Well, what do you need to know? So you can't tell how long that candle's been burning unless you know how big it was to start. The same thing for carbon-14 dating. We need to know how fast it's decaying, but we also need to know how much carbon-14 was in that creature to start with. If we don't know those two pieces, then we cannot do carbon-14 dating. The same thing, we wouldn't know how long that candle has been burning. For example, if we find 1,000 carbon-14 atoms in a fossil, do we know how much carbon-14 has decayed? No, we don't. See, we need to know the starting amount. We know how fast it decays, about 5,730 years. That's the half-life. So how do we know how many half-lives have expired when we find a fossil? We need to know the starting amount. We can find out how much is still in there today, but we need to know how much it started with. So how is this done? Well, it's done by using another form of carbon. There are two types of carbon used in the dating process. One is carbon-14 and the other is carbon-12. Now, carbon-14, we said, is the unstable isotope. And carbon-12 is a stable isotope. In other words, it never decays. It stays carbon-12 all the time. Now, when an organism is alive, it has the same ratio, carbon-12 to carbon-14, that we find in the atmosphere. In other words, when we take measurements in the atmosphere, we know we have gases like oxygen in there, we have nitrogen, and we have many other types of gases out there. And these happen to be carbon. And there's different types of carbon in the atmosphere. One is carbon-12, one is carbon-14. And we take a measurement of this ratio in the atmosphere. And we find for every 1 trillion carbon-12 atoms, there's 1 carbon-14 atom. And since we're breathing all this in, we eat creatures that have all this in, we eat plants that have this in, we should have the same ratio inside us that we find in the atmosphere. That is 1 trillion to 1. So when we're alive, we have that ratio. But once you die, that ratio begins to change. Now, why does it begin to change? Because once you die, you're no longer taking in any carbon. You're no longer taking in any carbon. Now, the carbon-12 in that dead organism stays constant because it does not decay. It stays in there. But what does the carbon-14 do? It begins to decay, continues to decay. So what we'll see when an organism dies, that ratio begins to change because the carbon-12 stays the same, but the carbon-14 gets less and less and less. So that ratio of 1 trillion to 1 will begin to change. It will become a much higher ratio. So the clock really starts at that point. And that's what we use to determine the starting amount. The starting amount is based on the ratio we see in the atmosphere today. So let's take a look at an example how this works. How the C12 to C14 ratio helps us understand the carbon-14 dating. Now, let's suppose on the left-hand column we have the amount of stable carbon-12. Now, that will remain the same all up and down this column because carbon-12 is stable, it never decays. Then the second column we have the amount of unstable carbon-14 we find in a fossil. Then we'll put that in a third column called the ratio. Then we'll have another column called years dead. How many years has this creature been dead? And we'll measure that in terms of half-lives in the right-hand column. For example, we find a fossil, and we find 100 trillion carbon-12 atoms. Now I'm going to use very simple figures here to keep the mathematics easy to understand here. So we find 100 trillion carbon-12 atoms, and we find 100 carbon-14 atoms in there. That is a ratio of about 1 trillion to 1. So how long has it been dead? Well, it just died because it has a half-life. No half-lives have expired. So it's just dead. But let's take a second one. We find 100 trillion carbon-12 atoms. Again, that's what we'll find in every case. But we only find 50 carbon-14 atoms. That gives us a ratio of 2 trillion to 1. That means 1 half-life has expired, and it's been dead about 5,730 years. That's how this ratio helps us understand the dating. Well, let's take a third one. Again, we get 100 trillion carbon-12 atoms. But we only find about 25 carbon-14 atoms. Because why? Because that carbon-14 continues to decay after the creature's dead. So 100 trillion to 25 gives us a ratio of about 4 trillion to 1. That means 2 half-lives have expired, or about 11,460 years ago is when that creature died. Well, let's take another scenario. Again, 100 trillion carbon-12 atoms, but we only find about 12 carbon-14 atoms. That gives us a ratio of about 8 trillion to 1, or about 3 half-lives have expired, or it's been dead about 17,190 years. That's how we do the dating. Another scenario. Again, 100 trillion carbon-12 atoms, but we only find about 6 carbon-14 atoms. That is a ratio of 16 trillion to 1. So that means 4 half-lives have expired, or about 22,920 years ago is when that creature died. And finally, we find 100 trillion carbon-14 atoms, or carbon-12 atoms, and only 3 carbon-14 atoms. That's a ratio of about 32 trillion to 1, or about 5 half-lives, or about 28,650 years ago is when that creature died. So you see this process. We have to use carbon-12 to get this ratio that helps us get this starting point. We assume now, notice the word assume, we assume that the ratio we find in the atmosphere today is the same it's always been, 1 trillion to 1. Notice there's this assumption there. And this is a critical assumption. In other words, has the ratio of carbon-12 to carbon-14 always been the same, 1 trillion to 1? Because remember, this ratio is what gives us our starting point, which is a critical detail. If that ratio hasn't been the same, then maybe this doesn't work as well as we've been led to believe. So this is the key assumption. If this assumption is true, then carbon-14 is a reliable dating method back to about 60,000 years. However, if this assumption is false, then the carbon-14 dating method is not a reliable dating method. So we have to go back now and examine this assumption. Now, Dr. Willard Libby, he is the founder of carbon-14 dating. Now, Dr. Willard Libby was an evolutionist and believed the Earth is billions of years old. Now, in his studies, he noticed that we were not in equilibrium. He's the founder of carbon-14 dating method. He noticed we're not in equilibrium. He noticed that we were almost 25% out of equilibrium. Did that bother him? Well, a little bit. But what did he do with that 25%? He chalked it up to his margin of error. Now, before we criticize Dr. Libby, and we shouldn't, he had a reason for believing that. So he believed this Earth is 4.5 billion years old. Now, if we started with no carbon-14 in the atmosphere, remember carbon-14 is constantly being produced in the atmosphere by cosmic rays. So according to evolution, when this Earth was first formed, there would be no carbon-14 in the atmosphere. The measurements we have done show that if we started with no carbon-14 in the atmosphere, it would take about 30,000 years to build up to this equilibrium stage. Remember that bathroom sink we had? We turn on both faucets. We have the holes all up and down the side. What initially happens? Initially, the water's coming in so fast it starts to build up and up and up. And then eventually it hits enough holes where the amount that's coming in equals the amount that's going out. But it didn't happen instantaneously. It took a few seconds for it to build up. The same for carbon-14 build up to equilibrium. If we started with no carbon-14 in the atmosphere, it would take about 30,000 years to eventually build up to this equilibrium. Well, Dr. Willard Libby assumed the Earth is 4.5 billion years old based on evolutionary thinking. Therefore, we must be in equilibrium. So when he noticed we're about 25% out of equilibrium, he just chalked that up to something wrong in his calculations and was ignored. Now, Richard Milton, in his book, Shattering the Myths of Darwinism, writes this about Willard Libby. He found a considerable discrepancy in his measurements, indicating that apparently radiocarbon was being created in the atmosphere somewhere around 25% faster than it was becoming extinct. Since this result was inexplicable by any conventional scientific means, Libby put the discrepancy down to experimental error. In other words, based on his belief and assumption in evolution, he ignored the facts. Isn't that amazing what evolution will do to our thinking? Well, several years later, during the 1960s, Libby's experiments were repeated by other chemists. The new experiments, though, revealed that the discrepancy observed by Libby was not merely an experimental error, it did exist. So Libby, based on his evolutionary thinking, totally ignored the scientific evidence. Now, even more, the facts about equilibrium. In the Review of Geophysics in 1963 states this: there is strong indication, despite the large errors, that the present natural production rate exceeds the natural decay rate by as much as 25%. In other words, carbon-14 is being produced into the atmosphere over 25% faster than it is decaying. And folks, this was the critical assumption. And we stated if this assumption was true, then carbon-14 is valid. If it was not true, then it is not a reliable dating method. And look what we knew 40 years ago. 40 years ago, we knew conclusively that the assumption was false. But for over these 40 years, that assumption has been ignored in our public classrooms. Why? For one reason, the same reason Libby ignored it. He believed in evolution so much that the scientific evidence does not matter. Now, we know the production rate is much faster than it's being removed, but are there any factors that could affect the production rate? And yes, there are. Factors that could affect the production rate include cosmic ray penetration of the Earth's atmosphere. In other words, if there's something out there that affects the amount of cosmic rays striking the upper atmosphere, that would change the amount of carbon-14 being produced. The strength of the Earth's magnetic field would affect that, because we have a magnetic field around this Earth that protects us. And if that is getting weaker and weaker, then more cosmic rays can enter, producing more carbon-14. And in fact, the magnetic field is decaying. The carbon dioxide levels in the atmosphere would affect it, and the Genesis flood would affect the amounts of carbon in the atmosphere. Let's take a look at the Genesis flood. Genesis flood and atmospheric levels of carbon. The Genesis flood, we know, buried much carbon from living organisms to form the coal and oil we see out there today. Matter of fact, this buried carbon, which is mostly carbon-12, is about 100 times the total carbon in the present biosphere. That means there was much greater carbon-12 in the atmosphere before the flood. What would that do to the ratio? It would completely change the ratio from 1 trillion to 1 to something much higher, like maybe 16 trillion or 32 trillion to 1, or maybe even more. So what does this mean? The carbon dioxide levels in the pre-flood biosphere were different. A higher ratio of C12 to C14. C14 dates using the present ratio to C12 to C14 will then give incorrect dates. They'll give a date that's much older than it really is. Let's take a look at an example of these dating assumptions. Let's suppose we find a fossil, and we measure the ratio to be 16 trillion to 1. That's C12 to C14. That would indicate about 4 half-lives of expired, or about 23,000 years. So that means that creature died about 23,000 years ago. Because remember, when something dies, the clock starts. Because when that creature dies, it no longer takes in any carbon. But the carbon-12 stays stable, and the carbon-14 continues to decay. So we measure the half-lives. Now, what if the ratio actually started out as 2 trillion to 1 versus 1 trillion to 1? That would mean our dating was all wrong. That would mean only 3 half-lives have expired rather than 4, or the creature is only 17,000 years old versus 23,000. But what if the ratio was 8 trillion to 1 at one time? That would mean only 1 half-life has expired and not 4, and that would mean this creature died only about 5,000 years ago rather than 23,000 years ago. You see, the flood would make a very big difference in our dating methods. And we know there's more carbon in the ground today than anything that exists today. More has been buried to form all this coal and oil. We don't see coal and oil being produced the way it is in the ground today. Where did it all get there? It took a tremendous amount of vegetation. Tremendous amount of vegetation had to be buried to form all the coal and oil we see today. Because we don't see it happening today. That means there would have been greater C12 levels in the atmosphere thousands of years ago before the flood, which would have skewed the ratio. Instead of being 1 trillion to 1, it might have been up to 32 trillion to 1 or higher. So the assumption in equilibrium. We know that the assumption that the biospheric inventory of C14 has remained constant over the past 50,000 years or so is not true. See, even people who accept evolution know full well that this ratio has been changing. Notice the ratio has not always been 1 trillion to 1. It's been much greater. And what does that do to our dating? It tells us that all our dates we take today will give an age much greater than is really true. So, bottom line is, the assumption that carbon-14 is based on has been proven false. Now the question is, have we ever read that in a textbook? And the answer is no. Why? One reason. The evidence does not matter. All that matters is we believe in evolution. So let's look at carbon-14 and age. One more thing on carbon-14. Anything older than 60,000 years should have no detectable carbon-14 in it. In other words, after about 10 half-lives, all the carbon-14 should have decayed out of an organism, out of a fossil. If we detect carbon-14 in one of these fossils that is supposed to be over 60,000 years old, then it is good, strong evidence that fossil is not that old. Now, coal. The assumption is that coal takes hundreds of thousands of millions of years to form. So based on that assumption, we should not find any carbon-14 in coal. However, every sample of coal we take today, we're finding detectable carbon-14 in it. Now, what does that mean? It means this, that the maximum age that coal can be is about 60,000 years. Now, I'm not saying the coal is 60,000 years. What we're saying is putting a maximum limit on that coal is 60,000 years. If there's still detectable carbon-14 in that coal, it cannot be older than that. Fossil woods estimated to be over 200 million years old. We are still finding detectable carbon-14 in it, meaning what? That wood cannot be that old. So carbon-14 in recent dates. Here's a new article out. It states this: ancient human skeletons, when dated by the new accelerator mass spectrometer technique, give surprisingly recent dates. In one study of 11 sets of ancient human bones, all were dated about 5,000 radiocarbon years or less. Now, these are the creatures, these are the former human fossils that are supposed to be tens of thousands of years old. In every single case, using carbon-14, using the right method, we found enough carbon in them to date them only about 5,000 years ago. So, carbon-14 summary. Carbon-14 can only be used to date organic material because people, animals, and creatures take in carbon-14, rocks don't. So the next time you're out there and you go to one of these rocks or fossil shops and you find this rock that they've got dated there at 40 million years old, and you ask them how they know this, and they say it was carbon-14 dated, you can start asking for a discount because they can't use carbon-14 to date rocks. Carbon-14 dating accuracy is dependent upon a consistent ratio between carbon-12 and carbon-14 called equilibrium. This assumption has been proven false. And we also saw there are factors that affect the production of carbon-14 in the atmosphere, and one of the biggest ones would be the Genesis flood. We've also seen that ancient fossils as well as coal still have detectable carbon-14 in them. All of that shows that carbon-14 cannot be used as being taught in our textbooks. And one more thing about age. We stated earlier that if we started with no carbon-14 in the atmosphere, it would take about 30,000 years to build up to this equilibrium. And what we've also noticed is that we are over 25% out of equilibrium. Now, if it only takes 30,000 years to build up to equilibrium, and we're still not in equilibrium, what might that suggest? Well, it might just suggest that this earth is not that old. You see, when we learn our real science, and not just accept evolution as true, but we go in and study the science, we find it does support the biblical model of a young earth. Carbon-14 dating conclusion out of the Radiocarbon Ages and Error Anthropological Journal of Canada 1981 states this: the troubles of the radiocarbon dating method are undeniably deep and serious. Despite 35 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged. It should be of no surprise then that fully half of the dates are rejected. The wonder is that the remaining half came to be accepted. And they conclude, the implications of pervasive contamination and ancient variations in carbon-14 levels are steadfastly ignored by those who base their argument upon the dates. While the method cannot be counted on to give good, unequivocal results, the numbers do impress people and save them the trouble of thinking excessively. In other words, people are just accepting carbon-14 for various reasons. One of those reasons is they believe in evolution and the evidence doesn't matter. A second reason is nobody teaches how evolution and how carbon-14 really works. So they go on believing carbon-14 is an accurate, reliable dating method without ever being taught the real evidence. So let's go into the second part now. Radioisotope dating methods. Now what we're going to look at is those methods that we date rocks. We just looked at the method for dating organic material, carbon-14. Now, how do we determine the age of the Earth? How do we date all these rocks? And what we want to look at is this. What are they and how do they operate? How do radioisotope dating methods work? What is the basic perception? How accurate are they? And are there any hidden assumptions? Didn't we just see a hidden assumption in carbon-14? Now, if that dating method does not work, and it's reported as an absolute reliable dating method in our textbooks, can we trust the radioisotope dating methods? Well, let's take a look. Let's first of all see, why do people believe in an old Earth? Well, first of all, they believe scientists have proven the Earth to be old. Peer pressure, specifically in the education system. Intellectualism. We hear science versus religion. Some people just don't want to hear the real information. They just want to believe evolution. Don't bother me with the facts. Don't bother me with the scientific evidence. I'm just fine believing in evolution. We hear young earthers. People believing in young earth are ignoring the scientific evidence. Well, that was not the case in carbon-14. What we find out there was people believing in evolution don't want to hear the information. We also see the Bible does not teach how old the earth is. Yes, it does. The Bible gives a very clear indication that this earth is very young. We also hear things like, it's not important, but it must be old. And finally, we hear things like, most scientists believe the earth is old. Well, that's true, but there are thousands of scientists that don't. And finally, pride. People just accept the earth is old based on pride. Well, let's see what our textbooks have to say about the age of the earth in radioisotope dating. And this is what they say out of a 1998 biology textbook. Using radioactive dating, scientists have determined the earth is about 4.5 billion years old, ancient enough for all species to have been formed through evolution. In other words, they're teaching the earth is old, billions of years old, as a fact, not even bothering to question how the process works. We saw that in carbon-14. They just assume it is an absolute reliable dating method without even questioning or teaching how it works. They just assume evolution is true. Well, let's go to radioactive decay. How does radioactive decay work? Well, we start with something called a parent element and a daughter element. For instance, uranium would be the parent element. And over time, uranium gradually radioactively decays into lead, the daughter element. There are many forms of this radioactive decay process. Another one is called potassium and argon. Potassium being the parent element, and over time it will radioactively decay into argon. So that's what we mean by radioactive decay. We saw the same thing in carbon-14. It decays from carbon-14 into nitrogen-14. And that was used to date organic material. Now, these other radioisotope dating methods are used to date rocks. They have a much longer half-life. Some of these half-lives are in the billions of years. So we use those to date things like the age of the Earth. Now, how does this radioisotope dating work? Well, first of all, radioisotope dating methods are used to date igneous and metamorphic rocks, such as basalt, lava flows. They cannot be used to date organic material or sedimentary rocks, such as limestone, sandstone, or shale, which is most of this planet. Can only be used to date once molten hot rocks that then cooled. Well, why? Well, when a rock is in its molten state, it is assumed, notice I use that word assumed again, that all the daughter element leaks out. And it starts with just the parent element. And once it solidifies, the radioactive decay process starts. For example, uranium to lead. What we see here in this whole process, uranium-238 gradually decays to lead, but it does it in many, many steps. For example, you have uranium decaying into thorium, then into protactinium, and then on down the line and eventually into lead. And once it gets down to lead-206, it stays lead-206. It's a stable isotope. So it radioactively decays. Now, what we assume here is if we were to find a rock and find some lead-206 in it, find some lead, we assume that all that lead is due to radioactive decay once that rock solidified. Again, we're assuming during the molten state of that rock, all that lead seeped out. So when we find a rock with some lead in it, the assumption is all that lead is due to radioactive decay. Now, let's see how this process works. Let's see if there's any assumptions in here. Let's suppose I were to start with an hourglass. And we've seen these hourglasses. Those are the things where we have the sand falling down, looks like this, and we have the sand falling down. We use them in our games a lot. So we have an hourglass. Let's suppose I have an hourglass up here that you can't see. And what I'd say is this. What I want you to do is take off all your timepieces and step outside. And once you've stepped outside, I'm going to start this hourglass. So you take your timepieces off, you step outside, and I have the hourglass up here. Then after a period of time, I say, come on back in. And then I ask you the question, how long have you been standing out there? So you take a look at this hourglass. And some of you can look at this hourglass and calculate how fast that sand is falling down. Then you could calculate, say, how much sand is on the bottom. And you might come up with a formula and come up with an answer of, maybe, Mike, we were standing out there about 25 minutes. And I might respond this way. Your calculations are exactly right, but your answer is wrong. What? Now, how could you do all the right calculations and come up with the wrong answer? Well, you started with some assumptions. You see, once you left out that door, you never got to see the hourglass until you came back. How do you know when I started that hourglass? I might have waited 5 or 10 minutes. You don't know that. How do you know there wasn't some sand already on the bottom? You don't know that either. How do you know that sand fell at a constant rate? I could have been going tap, 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 making it fall at a different rate there. You don't know that either. How do you know I didn't open that hourglass up and take some sand out or put some sand in? You don't know that either. See, all your calculations could be correct, but your answer could be absolutely wrong because you started with some assumptions. In this case, they could have been absolutely wrong. So let's take a look at 4 assumptions that are used in radioisotope dating. Number 1, the starting amount of daughter element is known. We must know the starting amount of the daughter element. And it is assumed that it starts with no daughter element. Think about that hourglass. How do you know there wasn't some sand on the bottom to begin with? We don't know that. Number 2 assumption, all the daughter element is due to radioactive decay. We don't know that either. It could have started with some daughter element, such as lead. Number 3, the sample was always in a closed environment. For example, that hourglass, how do you know I didn't open it up and add some sand to it or take some sand out? The same thing for rocks. They sit out there for millions and millions of years, according to evolutionists. How do they know it's been a closed environment? How do they know some elements like water didn't seep through those rocks and cause elements to be subtracted or added? We don't know that. And assumption number 4, the decay rate has always been constant. We don't know that either. You see, just like that hourglass, how do you know I didn't go tap, 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 make the sand fall a different rate? See, in laboratories, we can alter the decay rate. So isn't it possible it could also happen by natural processes? See, all of these are assumptions. And if you're basing your dates on all these assumptions and you can't prove these assumptions, all your calculations might be true and your answer completely wrong. So let's take a look at some examples of dating. See how accurate this method is. Sunset Crater in northern Arizona, a large volcanic area. They did some potassium-argon dating. This is one of the most often used for volcanic rocks. They dated this using potassium argon and dated these volcanic rocks as over 200,000 years old. Reality was, those rocks were formed by volcanic eruption in 1065 AD. We are about 1,999 years off. Why? Because we started with an assumption we couldn't prove. All our calculations could be right, but our answer could be very wrong. Lava flows in New Zealand. Potassium argon dated these rocks at 275,000 years old. In reality, these rocks were formed in eruptions from 1949, 1954, and 1975. Now we're about 273,000 years off. Again, we based our answer on assumptions we couldn't prove. Hawaii, lava flows. Potassium argon dated these lava flows between 1.4 and 22 million years old. Reality, those rocks were formed from an eruption in 1801. Now we're not just thousands of years off, we are millions of years off. See, if you start with these assumptions, all your calculations can be true, but your answer can be very wrong. Mount Etna, basalts in Sicily. Potassium argon dated these rocks between 140,000 and 350,000 years old. Reality, those rocks were formed in 1972. Again, you have to know your assumptions. You have to take into account the assumptions, because if you don't, all your calculations can be true and your answers can be completely false. And that's what we're finding out with the radioisotope dating. Some more examples. Rocks that were created in the Mount St. Helens eruption in 1980 were dated up to 2.8 million years old. Clear evidence, we have observable evidence how old those rocks are. The dating doesn't appear to work very accurate. Let's look at some more. Grand Canyon. Grand Canyon. What we did, we sent some scientists down to the bottom of the Grand Canyon to get what are supposedly the oldest rocks in the canyon, all the way down to the Gardenia basalt, down to the Precambrian area. Oldest rocks. And we took those rock samples and took them to a laboratory. Now, one of the things you must understand, a lot of times when they take these samples to laboratories to be dated, the first thing they do is they tell the laboratory where they found the rocks. That's the first thing we do wrong, because that biases the experiment right there. Then they usually say, put on there, we expect these rocks to be within this range. That's another bias for the experiment. So what these scientists did, went down to the Gardenia basalts in the Grand Canyon, got some rock samples, took them to this laboratory and just said, date these rocks. They did not bias the experiment. Just date these rocks. And they dated these rocks using many different formats. They did 5 potassium argon models, 6 rubidium strontium, 1 potassium argon isochron, and 1 rubidium strontium isochron. And notice the different ranges of the dates we got. That alone should invalidate the whole dating process when you get so many different ranges of dates. So which one did they choose? Well, they chose the 1 rubidium strontium isochron. And they dated this rock at 1,070,000,000 years old. So then what we did, we took some scientists to the top of the Grand Canyon and dug out some of the supposed youngest rocks. And we took them to the same laboratory and said, would you date these rocks? We did not bias the experiment. And they went through the multiple dating processes and come up with many different ages. And which one did they choose? Well, since they used the rubidium strontium isochron before, they decided to use that one again. And they dated the youngest rocks at 1,340,000,000 years old. That is over almost 300 million years old than the oldest rocks. In other words, the youngest rocks were much older than the oldest rocks when we did not bias the experiment. So how reliable is radiocarbon dating, radioisotope dating? Well, if the dates are never right when we know the age of the rocks, how can we be sure they are correct when we don't know the exact date of the rocks? You see, the trustworthiness of radioisotope dating is not there. Every time we know the age of a rock, the radioisotope dating never works. So how could we trust it when we don't know the age? John Morse, PhD in geology, in his book, The Geology Book, writes this about the reliability and consistency of radioisotope dating. And he says, when the same rock is dated by more than one method, it often yields different ages. And when the rock is dated more than one time by the same method, it will often yield different results. That alone should tell us it doesn't work properly. But the public never hears any of this. That is called indoctrination. It's called deception by omission. The evolutionist model is unwilling to present all the scientific evidence. Why? Because if they did, evolution cannot stand up against the science. So assumptions again. If you base your theory on a wrong assumption, all your work can be correct, but the result can be very wrong. Now, we've talked about this radioisotope dating not giving accurate dates. We talked about carbon-14 dating not working. But is there any scientific evidence that this Earth is young? And the answer is yes. Let's take a look at this radioisotope dating again. Let's take a look at something here. Call this conflict in dating. In 1993, scientists found some wood, some trees, buried in basalt flows about 69 feet deep. So about 69 feet down in there, we found some basalt, some lava flows. And buried within those lava flows, we found some wood. Now, wait a minute. How in the world could that wood get in those lava flows? It had to get in there when that lava was still molten. Had to be in there when that lava was still molten and then hardened. Now, we took those wood samples, we dug out those wood samples and took them to two very reputable labs for doing carbon-14 dating, because wood is organic material. Took them to those labs, and they concluded that that wood was 44,000 years old. Now, we know carbon-14 dating is not reliable beyond a few thousand years. But that lab dated this wood at 44,000 years. That means that rock should be the same age. That rock should be the same age. So we took that rock sample, that basalt, to a very reputable lab for doing radioisotope dating. And they dated that rock at 45 million years old. Something is not right with the dating methods. That wood and that rock should be the same age, but it is not, according to the evolutionist's own model. Now let's take a look at some evidence of young Earth. Helium in the atmosphere. Now helium regarded as the Teflon of atoms. It's the Teflon of atoms. It's the second lightest of all the elements. I call it the Teflon of atoms because helium does not like to stick to anything. It just migrates up through the Earth's crust and on up in the atmosphere. Now, uranium, we mentioned, gradually decays into lead over a whole series of processes. In other words, uranium to thorium to protactinium and on down. Now, during this process of uranium gradually decaying to lead, we form some alpha nucleus or some alpha atom or helium atoms. So some helium atoms are formed in this process. Now, what happens to these helium atoms? Well, these helium atoms are now in the Earth's crust. And these helium atoms, again, are like the Teflon of atoms. They don't like to stick to anything. So they migrate through the rocks and on up into the atmosphere. So as these helium atoms are going into the atmosphere, if this Earth was 4.5 billion years old, and that radioactive decay has been going on for 4.5 billion years, we should have so much helium in the atmosphere, we should all be talking in very high voices. But we're not. When we take a measurement of the amount of helium in the atmosphere, there's only enough for a young Earth. Something does not match the evolution scenario. Where is all the helium? Well, it escapes into outer space. We hear it escapes into outer space. No, it doesn't. We've done the tests. We've done the experiments. Yes, some helium can escape into outer space, but the experiments show only very little. There's simply not enough helium in the atmosphere for a 4.5 billion year old Earth. Helium in granite. Remember, helium is our Teflon of atoms. Through this radioactive decay process, uranium to lead, it produces helium atoms along the way. Now, helium does not remain long in rocks because it just kind of migrates on up into the atmosphere. Now, if the Earth is billions of years old, we should not find large amounts of helium in this granite, specifically the zircon crystals. It should have all migrated out a long time ago. The problem is, for the evolutionist, that over 58% of this helium still remains in the granite, the zircon crystals. It should not be there. If this Earth is 4.5 billion years old, all that helium should have migrated out a long time ago. So what does it mean that we're still finding so much helium in these granite rocks? Well, it means this. There has not been enough time for the helium to diffuse out of the granite. The evolution model of billions of years does not match the data. What matches the data is the creation model of a young Earth, about 6,000 years old. You see, when you do the science, it matches what the Bible teaches. When you read the textbooks, what we're finding out is a lot of deception going on. We need to get back to putting all the scientific information into our classrooms and get away from indoctrination and deception. You know, there's many scientists out there today working on these projects, radioisotope dating projects. There's a group called the RATE group, called Radioisotope and the Age of the Earth, a group located at Institute for Creation Research. We have a whole group of scientists working specifically on this whole concept of age dating. We have geophysicists, atmospheric scientists, physicists, nuclear physicists, geologists, geological engineering, biologists, even a person who's a Hebrew scholar to examine what does the Bible teach. So we have a whole group of scientists working specifically on this, and what they're finding out is, and confirming, is that carbon-14 dating does not work. And we knew it a long time ago. They're finding out that carbon-14 dating supports a young Earth because we consistently find carbon-14 residue in coal and in bones that are supposed to be hundreds of millions of years old. They're finding that the radioisotope dating does not work as being reported in our textbooks. What they are finding out is things like the amount of helium still found in granite rock supports a young Earth. See, they're doing the original research. They're not just assuming evolution is true. They're not just assuming the Earth is billions of years old. They are doing the real research. And what we're finding out is there are many scientific evidences of a young Earth. For example, we talked about helium in the Earth's atmosphere. Nuclear decay rates we've seen. There's not enough nuclear decay rate to have gone on for billions of years. If there was, we should not find all that helium in the granite rocks. Sodium in the oceans. There's not enough sodium in the oceans for billions of years. Rapid disintegration of comets shows this solar system can't even be that old. Erosion of the continents. If the erosion rate is going on like it is today, all these continents should be flat, but they're not. Sediments on the ocean floor show the Earth is not that old. The decay of the Earth's magnetic field. Carbon-14 ratio in the atmosphere. Radiohalos for polonium in granites. Population statistics. Recession of the moon. And many more scientific evidence clearly show this Earth is not old enough for evolution to have occurred. And even if the Earth was billions of years old, we can show biologically and through chemistry that evolution can't happen. So who believes in a literal 6-day creation? There are many scientists out there. And I know we get, in our textbooks, we hear things like in classes, there are no real scientists that believe in creation. They all believe in evolution. Well, that's false. That's making a statement without doing any research. First of all, we got the whole RATE group, the radioisotope dating group. Then we have astronomers, astrophysicists, condensed matter physicists, geologists. Every area of science, we have scientists that have earned PhDs from some of the top schools in this country that believe in a 6-day creation about 6,000 years ago. Even many Hebrew scholars will agree with that today, that the Bible clearly teaches a young Earth. So belief in a young Earth, Keith Wadsworth, PhD in condensed matter physics, says this: I am convinced there's far more evidence for a recent 6-day creation and a global flood than there is for an old Earth and evolution. Why does he believe that? 2 reasons. One, the Bible teaches it, and secondly, he can support it scientifically. So, conclusion. 5 facts in our conclusion. Number 1, the Earth has not been scientifically proven to be billions of years old. Secondly, the Bible teaches a literal 6-day creation. Third, many scientists believe in a literal 6-day creation about 6,000 years ago. Fourth, new evidence from nuclear decay rate supports a young Earth model. And 5, there are many scientific evidences for a young Earth. So we conclude from here. Psalm 118:8. It is better to trust in the Lord than to put confidence in man. And John 17:17, sanctify them through thy truth. Thy word is truth.
This video presented some amazing facts very seldom seen in textbooks and journals about carbon-14 and other dating methods. We saw that carbon-14 dating, when fully understood, does not support evolution, but rather a young Earth. We saw that the dating methods are based on faulty assumptions. Finally, we saw that the new research in radioactive dating methods supports a biblical model of a young Earth. If you'd like more information on the subject of creation, including other DVDs and products by Mike Riddle, visit the website www.traintoequip.com. Thank you, and remember Colossians 1:16.